Hello. Um, in this video, we are going to take a look at how to make a list of all the possible rational zeros or solutions to a higher degree polynomial. Okay, so um, in the last video, you looked at how to use synthetic division, and what we're working up to is how to solve higher degree polynomials that are not factorable. And we use synthetic division um, in, in order to find these solutions, or what we call zeros. Okay, so take notes. Finding rational zeros of higher degree polynomials. Okay, so we use what's called the rational root test. Okay, so, but before we go into that, let's make sure you understand what a zero is. Okay, um, so just some vocabulary here. Uh, Zeros are the solutions. Okay, another way to call them are roots. Roots are also the solutions. Okay. So whenever you hear or you see directions that say find the zeros or find the roots, they're basically asking you to solve. Okay. All right. So here we're taking a look at how to find all the different rational zeros, and what we're doing in this video is we're just looking at how to make our list. Okay. So we're working up to finding the solutions, the rational solutions, but we don't just start testing random numbers with synthetic division. We actually we actually pull from a list of very specific numbers. And so what we're taking a look at here is how do we develop that list? Okay. All right. So developing the list. Okay, so what we do here is we use what's called the rational root theorem. So rational root theorem, which states that if a rational root, that's a solution. So if a rational root of a polynomial exists, then that rational root has the form, and you have to remember a rational number, key word here, ratio. A rational number is a number that can be written as a ratio of two integers. Okay, so a rational number is like, 2/3 or -5/7. An example of a number that is not rational is like square root 2. Okay. All right, so if a rational root of a polynomial exists, then that rational root has the form p over q, where p is a factor of the constant the constant term in the polynomial, and Q is a factor of the leading coefficient. Okay, this will make more sense, and it's when I start doing an example. Leading coefficient. Okay, so here's an example. If you have a polynomial, p of x equals to 3x cubed minus 5x squared plus 7x minus, let's do 4. Okay. So over here, this here is your constant term, the one that does not have an x. Okay. And if you have them listed in descending order by exponents, exponent 3, 2, 1, and none. Okay. So x to the 0 is like 1. 1 times 4 is 4. Okay. So 3, 2, exponent 1, exponent 0. Okay. So if you have them written in order, then this here, this first term here, has what's called the leading coefficient. So the leading coefficient here is 3. Okay, so these two numbers play an important role in listing your possible rational zeros. Okay, all right, so let's take a look at finding the rational zeros. Let's list all possible rational zeros, and we'll do a bunch of examples. List all possible rational zeros of each. Okay. So here, let's do this first example. So suppose that I have this polynomial, x cubed minus x squared minus 15x minus 25. Okay, so here my constant term is negative 25, and so this here would be q. Okay, I mean p. All right, so this here is p. And here, this invisible 1 is your q. Okay, and so according to the rational root theorem here, it says if a rational root of a polynomial exists, then that rational root has the form p over q, where p is a factor of the constant term in the polynomial and q is a factor of the leading coefficient. Okay, so this here is your p and this here is your q. So here's p, here's q. So what I want to do now is list all of my factors of p. And so that would be all the positive and negative numbers that are factors of 25. So that's plus minus 1, plus minus not 2, 3, 4, 5, and plus minus 25. Okay, so these are all the factors of 25. Positive 1, negative 1, positive 5 and negative 5, positive 25 and negative 25. And then the factors of q. The factors of q are, well, q is only 1, so this is a little boring. Just positive 1 and negative 1. Those are the only factors of 1. Okay, so you list all the factors of p. You list all the factors of q. And then now your possible, so the directions say list all possible rational zeros. So your possible rational zeros are going to be all the combinations of these p's, these 6p over this one, well, these two q's. Okay, so it's going to be positive, negative 1 over 1, but that's just 1. Positive and negative 5 over 1, that's just 5. Positive and negative 5. Positive, negative 25 over 1. And that's just going to be positive, negative 25. Okay, so that's all you do. And so this here would be your final answer for this assignment. Okay, let's try the one that's up above here. Okay, this problem that I wrote up here. Okay, so p of x equals 3x cubed. I just sort of made that up. So let's 3x cubed minus 5x squared plus 7x minus 4. Plus 7x minus 4. Okay, so here is p. So I'm going to need all of my factors of 4. And this here, 3, that's my q. Okay, so let's do factors of p. So that's plus minus 1, plus minus 2, plus minus 4. Okay, those are all the factors of 4. Okay, let's list all of our factors of 3, of q. So this is q, so that's going to be plus minus 1, plus minus 3. Okay, all right, so once I have all of my factors of p and factors of q, then I can list my possible rational zeros or rational roots. Okay. All right, so they are all the combinations of p over q. So it's going to be plus or minus 1 over plus minus 1. That's just going to be plus minus 1. Plus minus 2 over plus minus 1. That's just plus minus 2. Plus minus 4 over plus minus 1. That's just plus minus 4. And then we have to do this q. So it's all of these p's over 3, plus minus 3. Okay, so that's going to be plus minus 1 over 3. Plus minus 2 over 3. And plus minus 4 over 3. Okay, so this here would be your answer. Okay, so list your possible rational zeros. Okay, so that's the direction. List all possible rational zeros of each. Okay, so that's all you do. You list all the factors of p, all the factors of q, and then you list all the combinations of all the p's over all the q's. 1 over 1, 2 over 1, 4 over 1. 1 over 3, 2 over 3, 4 over 3. But we have the positive and negative of all of those combinations. Okay, let's try another one here. Let's do one that's a little more interesting. Okay, this one looks pretty good. All right, suppose I have this polynomial, 10x cubed minus 2x squared minus 25x plus 5. Okay, so right here, this is p. Right here, this is my q. Okay, so my factors of p are going to be plus minus 1, plus minus 5. My factors of q are going to be plus minus 1, plus minus 2, plus minus 5, plus minus 10. Okay? All right, so my possible rational zeros are going to be all of my combinations of P over Q. Got a lot of Q's here. All right, so it's going to be plus minus 1 over 1, plus minus 5 over 1, plus minus 1 over 2, plus minus 5 over 2, plus minus 1 over 5, plus minus 5 over 5, plus minus 1 over 10, plus minus 5 over 10. Okay, so let's write them all down. All right, so plus minus 1 over 1, that's just 1. Plus minus 5 over 1, that's just 5. And now I have to do them all over 2. So plus minus 1 over 2, plus minus 5 over 2. And then I got to do the 1 over 5. All of these over 5. So that's plus minus 1 over 5, plus minus 5 over 5. But 5 over 5 is 1, right? And we already have 1. So I don't need to write this one. Okay? And then I have to do all of the p's over 10. So that's plus minus 1 over 10, and then plus minus 5 over 10. Okay, but plus minus 5 over 10, 5 over 10 is 1/2, and we already have it here, so I don't need this one either. Okay, so 1, 2, 3, 4, 5, 6 times 2, 12. So there are 12 possible rational zeros. Okay, so again, if you reduce it, you don't have to list it again if it's already listed. Okay, so hopefully you understand why I cancel this and say we don't need this one because 5 over 5 is 1, which is here, and 5 over 10 is 1/2, which is already here. Okay, all right, let's see. Let's do one more, and then you can try it on your own. Okay, suppose, actually this is letter D. Okay, so suppose that I have this polynomial here, 3x cubed plus 4x squared minus 17x minus 6. Okay. All right, so this is P, this is Q. Okay. All right, my factors of P are plus minus 1, plus minus 2, plus minus 3, and plus minus 6. My factors of Q are plus minus 1, plus minus 3. Okay? So now I can make my list of possible rational zeros. So it's going to be all of these guys over 1, all of these guys over 3. All right, so plus minus 1 over 1 is just 1. Plus minus 2 over 1, that's just plus minus 2. Plus minus 3 over 1, that is just plus minus 3. And then plus minus 6 over 1, that's just 6. Okay. Now I have to do all of them over 3. So plus minus 1 over 3. Plus minus 2 over 3. Plus minus 3 over 3. But 3 over 3 is 1, and we already have it. So I'm not going to list it. And then plus minus 6 over 3. Well, that's 2, and we already have that. Okay, so I'm not going to list it. So these are my possible rational zeros. Okay. All right, so go ahead and give it a try. You know what? Let's just do one more, and you try this one, and then check with my answers. Okay. All right, try this one. Let's see. Let's find a good one. All right, let's do this one over here. P of x equals, let's do 6x cubed minus 5x squared plus x minus 4. Okay, so this here is P, and this here is Q. All right, so factors of P. That's plus minus 1, plus minus 2, plus minus 4. Factors, so you should be hitting the pause button. If you didn't hit the pause button yet, go ahead and hit the pause button and then try it on your own and come back and check your answers with mine. Okay, factors of Q, plus minus 1, plus minus 2, plus minus 3, and plus minus 6. These are all the factors of Q, which is 6, okay? All right, so now your list, possible rational zeros. Remember, they have the form P over Q, so that's going to be all of these guys over all of these guys. So I'm going to start with this here. All of these over 1 is just going to be all of those. So plus minus 1 over 1 is 1. Plus minus 2 over 1 is just plus minus 2. Plus minus 4 over 1 is just plus minus 4. Now I'm going to do the 2's. So it's going to be all of these guys over 2. So plus minus 1 over 2. Plus minus 2 over 2. But 2 over 2 is 1, and we already have it, so I'm not going to list that. Plus minus 4 over 2. But 4 over 2 is 2, so I'm not going to list that either. Okay. All right, let's move on to 3. So it's going to be all of these guys over 3. Plus minus 1 over 3. Plus minus 2 over 3. Plus minus 4 over 3. Okay. And now I'm going to do the same thing with the 6. It's going to be all of these over 6. Okay, so plus minus 1 over 6. Plus minus 2 over 6. But 2 over 6 is 1 over 3. And we already have that, so I'm not going to list that. And then plus minus 4 over 6. 4 over 6 is 2 over 3. And we already have that, so I'm not going to list that either. Okay, so these here would be your list of possible rational zeros. So hopefully you got that. Okay. All right, if you have any questions, make sure you see me.